Good afternoon, everyone. Good afternoon. Okay, right. So today we discuss upon a topic in ElGamal Cryptosystem. So this is a type of encryption and decryption technique. Okay. So I'm going to change a teaching methodology today. So that type of teaching we call it as peer teaching methodology. Okay. So what is peer teaching? Peer is nothing but academic peers. If you are a student, your fellow friends are your peers. Okay, right. So I am introducing peer teaching methodology. So all of you search this topic and share your knowledge about this ElGamal Cryptosystem. Shall we start from here?
Crypto system was developed by ElGamal in 1980s.
Okay, good.
It's a simple algorithm where public and private key is used to encrypt the message and transfer.
In this ElGamal crypto system, the sender uses a random integer.
Towards the topic, right?
We have three steps: key generation, encryption, and decryption. In key generation, we select two integers, one prime number and one generator, and we choose two random numbers for private key. In public key, we use private key, and P and G we generate the public key.
Already we have studied one topic related to that. What is that?
Diffie-Hellman.
Yes, it is. It resembles Diffie-Hellman key exchange. Good, ma. Good, Harini. Good. Next, ma. Yes, sir.
It provides a strong security and it is used in blockchain and digital signature.
Good, ma. So she told the applications. So this system is used in blockchain and digital signals. DS algorithms. Okay, right. Then anybody? Yourself.
So it mainly used for secure the message over the insecure systems. So it mainly used in the cryptographic primitives. So it's like a DSA is a digital system algorithms.
Good. So we use a discrete logarithm technique in this. And one more point you have shared. What is that?
So it is ensure in the
Insecure.
area.
Yes, yes. To transfer data in an insecure network, we use this logarithm, this algorithm. Right. Then, anything missed? Good attempt. Next time I am expecting little elaborate explanations. Okay. So this teaching, like teaching, how a professor is teaching, taking a class like that, you have to teach your friends. Okay. So what is it? Various steps. At least every student have to speak at least 1 minute. I am expecting like. Okay, I'll start. Okay, right. So we discuss upon this topic now. The main objective is to understand mathematical background of this technique. So here discrete logarithm technique is used. The same thing that is finding perimeter or the exchanging key. So that concept is used in this ElGamal crypto system. Right. There are three steps as Harini told. One is key generation, encryption and decryption. There are three steps in this algorithm. Okay, right. In algorithm. So this is apply this simple encryption decryption scenarios. We can apply this in various simple scenarios. Next one. Right. So what is the problem statement here? So here the problem to Ravi. Ravi is a person working in a cybersecurity analyst. Need to implement a secure encryption scheme for transferring data over insecure cloud network. To transfer data in an insecure network, what is the logarithm? So that is the problem here. This is the problem statement. Next one. Define. So what is my empathize? So empathize is users. So user centric is this empathize part. So users are nothing but organizations, otherwise individual users. Okay. So users, that is organizations, developers want data, confidentiality and authentication in online transactions. So that is empathy part. Next one. So what is my definition? So we have to design a secure non-RSA public key encryption. So this is a non-RSA public key encryption. Next ma. So what is my idea? So here ideas, there are three ideas I have narrated here. One is RSA, second one is elliptic cryptography, third one is ElGamal. So we go for ElGamal. Next. So this is the steps in ElGamal crypto system. One is key generation. First step is key generation. To start with, here we are taking one prime number q. Okay, take prime number q. Q is a prime number. Then alpha. Here alpha is a primitive root of q. Okay, we all know what is primitive root. Alpha should be less than q. Okay, so alpha is a primitive root of q. Q is a prime number. These two are global public elements. Okay, next coming to key generation by Alice. Alice is sender, Bob is receiver. Imagine like. So Alice is sender. Okay, right. So select private key. First step is we have to select a private key XA. Okay. Just related with the numerical example, we'll discuss with one numerical example, right? So select private XA. That is XA should be less than Q minus 1. Okay, Q minus 1. XA, then calculate YA. What is the formula for YA? YA is alpha to the power of XA mod Q. So this is the formula. From using this formula, we can calculate YA. Then we can take from this we can calculate public key. Public key PU equals what is that? Q comma alpha comma OA. So this is my public key. This is private key. XA is my private key. Okay. Next one. The second step, encryption by Bob using Alice public key. Okay, right. So here my input text is plain text. We usually take like that as M. Okay, so M is my plain text, that should be less than Q. Here it is. Then select random integer K. So this is random key generator. Okay, that is we are taking that as small k. K should be less than Q. Okay. Then calculate capital K. K equals YA to the power K mod Q. It is like a Diffie-Hellman. It is like a Diffie-Hellman key exchange. Then, so calculate, we have to calculate capital K. It calculates C1 and C2. C1 and C2 are cipher text. Cipher text 1, cipher text 1, cipher text 2. Right. Cipher text 1 formula is alpha power K mod Q. Cipher text 2 is K mod Q. Okay. So usually the plain text is divided into various blocks. For each block we are taking that as cipher text 1, 2 like that. For each block K will be different. Okay. The key generated, that is the small k will be different. That is the strength of this algorithm. Right. From that, what is my cipher text? C1 comma C2 is my cipher text. This is encryption part. Then what is decryption? Decryption by Alice. Decryption by Alice. So cipher text we all have C1 and C2. From that, then again here also we have to calculate K. Okay, if you work out numerical example, this will be more clear to you. Right? So K equals again formula C1 to the power of XA mod Q. Using that private key. Okay, so encryption, decryption done. Calculate K. So from that, what is my plain text? We can find out plain text M equals C2 K inverse mod Q. With this formula, you can easily find out plain text. So this is ElGamal Cryptosystem, encryption and decryption. This one was Diffie-Hellman key exchange. Next one. Right. So what is the technical strength of this is security relies on discrete logarithm problem. Okay, computational complexity grows exponentially with key size. Okay, so key size can increase by used in digital signature algorithm as she told. Next applications used in cryptography, cyber security, blockchain, mathematics, and AI security. Thank you. Any doubts? Okay, right.